Dear students, welcome to VidyaVardhini Academy. Today I am going to solve the numerical problems on ray optics and optical instrument. The problem is like this. A double convex lens are to be manufactured from a glass of a refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 centimeter. Also find the new focal length of a lens if it is immersed in a water of refractive index 1.33. Okay, this is the problem. When you are going to solve the problem, you have to read the problem twice. See here what they have given. A double convex lens are to be manufactured from a glass of refractive index 1.55. That is, they have given refractive index of a glass, that is n of g, that is refractive index of the glass is, that is 1.55. Okay, and they have told both faces of the same radius of curvature, means the both faces are having the same radius of curvature, that is r1 is equal to r and r2 is also equal to r. Okay, r2, because they have same radius of curvature, but two faces are there. According to sign convention, we will take one side it is positive and the other side it is negative. Therefore I will take r2 as minus of r. Okay, find the radius of curvature required if the focal length is to be 20 centimeter. What we have to find out? We have to find out the radius of curvature, that is r. We have to find out if the focal length is, that is they have given the focal length, it is 20 centimeter. If the focal length is equal to 20 centimeter, then find the radius of curvature that they are asking. Okay, also find the new focal length. Okay, that is we have to find out the new focal length of a lens when it is immersed in water, that is FW we have to calculate, that is focal length of a lens when it is immersed in a water, okay, of refractive index, that is they have given refractive index of the water NW, that is refractive index of the water, it is 1.33. This is the things that has been given in a problem. Okay, then we have written whatever they have given. Now what we have to find out? First we have to find out the focal length. We know the formula, right? Focal length of a lens in a air is equal to, the formula is like this, that is 1 by FA is equal to NG minus 1 into 1 by R1 minus of 1 by R2. Just we know the things. Here we know 1 by FA, they have given focal length of 20 centimeter. I will consider like that only, 20 centimeter. I will take 1 by 20 is equal to, we know that is refractive index of a glass, it is 1.55 minus 1, okay, into 1 by R1. R1 is, it is capital R and minus of minus. Here R2 is also minus, therefore minus of minus it will be plus 1 by R. Okay. By using this, we will calculate the value of r here, that is 1 by 20. 1 by 20 is equal to, that is 1.55 minus 1, it is 0.55 into 2 by r. Okay, therefore r is equal to, I can write this equation as r is equal to 0.55 into 2 into 20. It is, that is 22 centimeter. Okay, that is, this is the radius of curvature. Radius of curvature of the two convex lenses is 22 centimeter. Okay, now the second question, they told that to find out the focal length of the lens when it is immersed in a water. Therefore we know the formula, that is FW, focal length when it is immersed in a water to focal length when it is in air is equal to NG minus 1 divided by NG by NW minus 1. We know everything, that is FW divided by FA is 20 is equal to NG is 1.55 minus 1 divided by NG is 1.55 divided by N of W, that is 1.33 minus 1. Okay, so we can write that is f of w is equal to, okay, 0.55 into 20 divided by 0.1654. So the FW is equal to 66.51 centimeter. This is the new focal length when it is immersed in water. FW is equal to 66.51 centimeter. Okay. Yes. Okay. Thank you for your attention. For more videos, follow VidyaVardhini Academy YouTube channel. Thank you so much.